Well, if it isn't my old nemesis, YouTube watcher. Today is Friday, September 23rd, 2022. I am, enjoying the beautiful fall weather here in Philadelphia. Got the windows open and it feels great. And today we're going to be working on the Elixir syllabus on Exercism. Today we're going to actually we're going to be working on two concepts: the Erlang libraries and randomness. And then we'll be working on the captain's log exercises. So easy for me to say. I'm going to read this and then I'll fill in other thoughts maybe at the end. Elixir code runs in the Beam virtual machine. Beam is a part of the Erlang runtime system. Being inspired by Erlang and sharing its run environment, Elixir provides great interoperability with Erlang libraries. This means that Elixir developers can use Erlang libraries from within the Elixir code. In fact, writing Elixir libraries for functionality already provided by Erlang libraries is discouraged in the Elixir community. Kind of true. As a result, certain functionality like mathematical operations or timer functions is only available in Elixir via Erlang. Erlang standard library is available for use in our Elixir code without any extra steps necessary. Erlang functions can be called the same way we call Elixir functions, with one small difference. The Erlang module names are snake case atoms. For example, to call the Erlang pi function from the math module, one would write :math.pi, braces, parentheses, and then you get pi. I never even knew we had pi. The most commonly used Erlang functions that do not have an Elixir equivalent are timer.sleep, which suspends a process for the given amount of milliseconds. That's a little weird because I feel like there's a thing called process.sleep. Rand.uniform, which generates a random float x, where x is 0.0 between 1.0, and the iolib.format, which provides C-style string formatting using control sequences. Using this function, we could, for example, print an integer in any base between 2 and 36, or format a float with the desired precision. Note that this function, like many Erlang functions, returns a char list. The math module that provides mathematical functions such as sine, cosine, log 10, and power to the power, not power to the 2, but power with 2 argument, and more. To discover Erlang Standard Library Explorer, the Standard Library Reference Manual. Cool. So yeah, there it is. What else do I have to say about Erlang? So actually, I want to see, because like when they talk about process, pretty sure, yeah, like there's a thing called process.sleep. Sleeps the current process for the given timeout. So some of that might be a little bit of some of this might be a little out of date in that like some things are available via Elixir native. But yeah, I mean in my day-to-day I don't go down to Erlang too often. Randomness is probably the one that I probably go down to the most for just generating random numbers. But as you'll see in the randomness concept documentation, there is another option if you have a collection. So in Elixir, to choose a random element from an enumerable data structure, e.g. a list or range, we use enum.random. This function will pick a single element with every element having equal probability of being picked. Elixir does not have its own functions for picking random float. To do that, we have to use the Erlang directly. I typically go down to Erlang for randomness and sometimes like cryptography, which you don't have to do that often. I mean, there's a lot of Elixir libraries that'll kind of wrap those domain concepts for you, but once in a while, you might want to go down. You might have to go down there. Yeah, they work really great together. Yeah, that's really all I have to say about that. Alright, so today we're going to be working on the captain's log exercise. Mary is a big fan of the TV series Star Trek, The Next Generation. She often plays a pen and paper role-playing game where she and her friends pretend to be the crew of the Starship Enterprise. Mary's character is Captain Picard, which means she has to keep the captain's log. She loves the creative part of the game, but doesn't like to generate random data on the spot. Help Mary by creating random generators for data commonly appearing in the captain's log. Oh boy, here we go. Alright, so we're gonna download our exercise. And we'll change our directory into it, and we'll open it up in VS Code. And we'll maximize the window. And let's see. So we got our main file. We're going to have our test file, which I will collapse for a second. And then we'll have our README. And I will close that. Okay. So let's get started. Task number 1, generate a random planet. The Starship Enterprise encounters many planets in its travels. Planets in the Star Trek universe are split into categories based on their properties. For example, Earth is a Class M planet. All possible planetary classes are D, H, J, K, L, M, N, R, T, and Y. Today I learned. Implement the random planet CrelIS function. It should return one of the planetary classes at random. Cool. Alright, so yeah, we're just going to start off with using that enum random function not reduce, random, that they mentioned, and this will just accept the planetary classes module attribute that they had built, which will statically create this list of those planet types. So I'm going to run all the tests, and I guess we don't see them if they're collapsed, so I will expand them all. So task 1, those are all passing, and now we will move on to task 2. Generate a random starship registry number. Enterprise registry number NCC 1701 is not the only starship flying around! Exclamation point. When it rendezvous with another starship, Mary needs to log the registry number of that starship. Registry numbers start with the prefix NCC, and then use a number from 1000 to 9999 inclusive. Implement the random ship registry number function that returns a random starship registry number. So here, once again, we're going to lean on enum.random, and we're going to use the range option. And that should be able to pick a random number between that range. I'm curious how they're going to test for the inclusivity. I'm curious how they're going to test any of these. I need to return NCC. Okay. So let's just do that. NCC, and that wind is picking up. But I don't care. I'm keeping my window open. I like it. Alright, I'll run all the tests. So that ends with a random integer between. Yeah, so they just run it kind of like once. Not that we'll get into it here because it's more of an advanced topic, but there is this concept called property-based testing, where basically you can create a test, and in the test you kind of declare a range of inputs and the expected outputs for that range. And so what will happen is that the property test will run the function a bunch, like not just like 100 or 1,000, like we're talking like 100,000 times, and it's kind of a way for you to kind of like really bulletproof your logic. So like if you have this expectation that like it takes a string from 0 to 100 characters, like it'll throw all kinds of string input at it, and you'll get to see like how your function fails, maybe because of some special Unicode character or something. They're not doing any of that here. They are running the test 100 times, and so I mean they're doing some little bit of due diligence there, but they're not running it they're not using property-based testing. They're just using the counter, which is fine. Cool. So now generate a random stardate, task 3. What's the use of a log if it doesn't include stardates, or it doesn't include dates? A stardate is a floating point number. The adventures of Starship Enterprise from the first season of Next Generation take place between the stardate 41000.0 and 42000.0. The 4 stands for the 24th century, the 1 for the first season, and the 1 for the first season. Oh, they're saying, I thought they were talking about the range of the entire series, but they're talking about season 1 ran from that stardate to that stardate. Okay. Implement the function random stardate that returns a floating point number between 41000 inclusive and 42000 inclusive. Okay. So this one is going to require us to do the Erlang random stuff because we cannot create a range based off floats. I mean, we could. I mean, you could if you always wanted to end a start date in .0, you could. I think they want us to. Yeah, they want the start date to end with a remainder. So we're gonna have to use the Erlang random stuff. So if we come back to the concept doc, they talked about rand.uniform, and they linked to the standard library. So we can come into here and we can look up random, and the unfortunate thing I think is that like they don't. The Erlang documentation is not nearly as like copy paste fun as the Elixir documentation, but so you don't get a lot of like copy paste examples, but it generally works the same way. So like, and this is kind of an important note too. Like when we talk about this module specifically, the random number generator is not cryptographically strong. If a strong cryptographic random number generator is needed, use one of the functions in the crypto module, and that is notable. Depending on what you're using this random stuff for. If you're just generating seed data or something, then it's fine. But that's fine. Oh, and it says use the rand module instead. Cool. Use spiller with a constant seed. Integer. Is there a way? Returns a random float uniformly distributed between and net. Let's see here. Erlang random float from range. So we get those, we get those. Then we get our lovely Stack Overflow. No, that's not what I want. Generate random numbers. Yeah, this I'm aware of. Is there a way to do that with a range? From 0 to 1,000. I mean, one way to do this. Well, that'll return. Let's open up a IEX module. So if like you do that, you'll get. Yeah, you can't pass it a. I mean, you could do it like this. I mean, here's one way to do it. I mean, you could say rand form. No, you gotta call it like this. I mean, one way to do this would be to say, okay, that's going to generate something random between, 0 and 1. You could instantly, multiply it by, what is this? 10,000. And that'll generate. That'll give you precision up to that, but that can be larger than we want. Returns a floating point number between 41,000 and 42,000. I mean, what I'm looking for basically is an amount between 0 and 1,000, because that is, and then I'll add it to, no, I don't want that. And then I'll just add the 41,000. And the other thing too is when you're writing floats, you can use this underscore to help signify like the breaks, the thousands and millionths breaks. That helps readability a little bit. All right, let me run the test. Let's see, so random start date is a float is equal to or greater than 41,000. This will run it 100 times. I want to do it 1,000 times just because I'm like paranoid. Run all tests. That looks good. And history, consecutive calls returns float with different fractional parts. That looks good. Returns floats with fractional parts with more than one decimal place. All right, cool. I think this is good enough. I mean, that's the like base range, and then we're just adding this to get to move that. Like the base range is 0 to 1,000, and then we're just moving it all the way up to 41,000, and then it'll be between 41,000 and 42,000. All right, cool. Number 4, in the captain's log, start dates are usually rounded to a single decimal place. Implement format starting a function which will take the floating point number and return a string with the number rounded to a single decimal place. Okay. I don't know. We got float. Ceiling, floor, round. Round sounds about right. Rounds a floating point value to an arbitrary number or fractional digits between 0 and 115 and 15. And then could you just do float to string? Probably. Start date one decimal place. Run all test. Those look good. This one does not accept integers. What are you supposed to do when you get an integer? You're supposed to assert arrays. Oh, they probably said that. Start date's usually rounded to implement format start date function that will take a floating point number and return a string with the number rounded to a single decimal place. Well, they never told you to add an assertion argument error. I mean, the way to do this is with a guard. Like you could do is float start date. That should accomplish that, right? No. What happens? Run this test. I said run this test. Apparently start date is not a good word. Okay. Let me say test cursor, run test at cursor. That works. Why don't you work? Run all tests. Does not accept integer. Mix test. Mix test. Expected argument error, got function clause error. Well, function clause error is more appropriate. Why? Does not accept an integer, expects argument error. Is it like, I mean, if I were to use float dot, what do I use? Round, like 100, like 1, 2, 3. Yeah, that's a function clause error. Why do they want an argument error? Does not accept integer. Elixir argument error. Who throws an argument error? Kernel, if you ask for elements and index is negative. This could be an Elixir change. So like I'm using Elixir 1.14, although they should have gotten that because they updated Elixir 14 in the Exercism repo already. Yeah, like if they're gonna test that argument raise is done, like they need to say that here, because they need to explain that more in the instructions. Unless I'm missing it. In the captain's log, start dates are usually rounded to a single decimal place. Implement start date, format start date. It will take a floating point number and return a string with the number rounded to a single decimal place. Expected argument error, but got function clause error. I'm gonna look at the Discord. I want to move this because we had a Discord where we were running the we were doing our Elixir cohort, and people were posting their solutions, completed exercises. So I'm gonna look for what is this, captain's log? Oh. Okay. So the mistake, and I think this is not really us, is that they want you to use the IO lib. They need to make a note of that because there's other ways to do that. So this is what they're looking for. They want you to use IO-lib format, so they want you to use the Erlang library, which makes sense because this is like, the exercise related to the Erlang integration. But they need to make that more clear in the instructions because it is extremely easy to solve that with Elixir. Yeah. Let me run the test on all tests. Still doesn't pass? No. Oh, I still, because that's because I have the guard statement. Alright, yeah, that passes. Let me run them here. There you go, green check mark. I'm gonna note this in my solution. I originally tried this, but it never passed the test. Was hard to understand why. I wish the README instructions was more clear that I had to use a Erlang call. Alright, and I'm gonna rewrap these. Wrap. And I'll just leave that there. The analyzer is probably gonna complain about that, but that's fine. Exercism, submit, lib. It passes. Let's look at the community solutions. They used enum random, that makes sense. They used random, finish, start, that's good. That's a much nicer that is a much nicer implementation. It captures the domain a lot better than mine. And then yeah, they used IO-lib format. Okay. So with that done, we're gonna mark our iteration as complete. We're gonna publish it, and we've unlocked 6 exercises. And cool. Awesome. Well, I want to thank you all for watching. Hopefully you enjoyed yourself. And if you have any feedback or questions, please do let me know. Other than that, have a wonderful weekend, everybody. I will see you next time. Bye-bye.